Hello, calculus friends. I am going to try to make this a quick video so that you can get some practice done while I'm not here. So we're going to today talk about the derivatives of inverse trig functions. So quick reminder on what inverse trig functions are. One purpose that they serve is, let's say I have a triangle and this is 6 and this is 8. And I want to know what angle theta is. I could say, well, tan theta is 6 over 8, which means theta is the inverse tangent of 6 over 8. And then you type that into the calculator, and the inverse tangent takes an input that's a ratio and gives you an output that's an angle. That's its purpose. Those kinds of things also have graphs associated with them. You can graph y equals inverse tan x, and believe it or not, it kind of looks something like this. And you can graph y equals inverse cosine x, also known, by the way, as arc cosine x or arc tan x, same thing. And inverse cosine x, I'm so bad at drawing this. It makes a little like S thing like that, but I'm terrible at drawing it, so type it in your own calculator and you'll see it. It's this weird funky S, but like I said, I'm bad at it. So if we can turn graphs out of these things, that means we can take the derivatives of those graphs and make tangent lines and slopes and all of that nonsense. So that's the plan today. Now, I'm going to do this and teach it a little bit backwards. We're going to start with me just giving you the answers, and then when I see you later, I will describe where these derivatives came from, because they kind of seem like they were dropped here by aliens. The derivative of inverse sine f of x, believe it or not, has nothing to do with trigonometry whatsoever. The derivative of inverse sine f of x is f prime of x divided by the square root of 1 minus f of x squared. Because it is. Deal with it. And memorize it. Sorry, not sorry. All right, next. If you want the derivative of inverse tan f of x, now I'm going to start calling f of x the end because it's easier. So if I want the inverse tan of an ending, x squared, 2x, x plus 5, doesn't matter. If I want to take the derivative of inverse tan of something, the derivative is the derivative of the end over 1 plus the end squared. And then last, but certainly not least, because it's definitely the weirdest, if you want the derivative of inverse secant, the derivative of inverse secant, where's another, we'll do this gray color. The derivative of inverse secant is the derivative of the end over the absolute value of the end times the square root of the n squared minus 1. Because it is, deal with it. Now, the good news is, yes, you have to memorize these, but technically you only have to memorize 3 of them, the 3 on the left. Because if you look carefully at the ones on the right, the derivative of inverse cosine is the negation of the derivative of inverse sine. The derivative of inverse cotangent is the negation of the derivative of inverse tangent, and the same with cosecant is just the negation of inverse secant. All right, now let's take some derivatives. So if we come down here and it says find f prime of x, where f of x is inverse sine 3x squared. So the way the derivative is written is that the derivative of inverse sine of f of x is f prime of x over the square root of 1 minus f of x squared. This is what I'm considering f of x. So the derivative of this thing is going to be the derivative of the end, 6x, over the square root of 1 minus the end squared. That's it. And then often what we'll do with this is, just because we have so many squareds going on and it's kind of hard to tell, is the squared under the radical or over the radical? That squared is very much under the radical. And 3x squared squared becomes 9x to the 4th. That's it. So if I come over here and says find g prime of x for g of x equals arc cos 4x plus 1. If I look up here, the derivative of arc cos is negative derivative over 1 minus original squared. Okay, so now I'm going to do that with a different color. We'll do red. So the derivative of arc cos is the derivative of the end, negated, over the square root of 1 minus the end squared. And I really don't feel like foiling that, so I'm just gonna leave it. There's your derivative. When we come here, blue, find the derivative dy dx if y equals x times inverse tan 2x. Well, we have a multiplication, so we need the product rule. Dy dx is the first times the derivative of the second. Okay, the derivative of inverse tan is f prime over 1 plus f squared. So the end's derivative over 1 plus the end squared. So there's the first times the derivative of the second plus the second times the derivative of the first. And I would very much encourage you to condense this because it's just kind of dangerous the way it's looking right now. If you miss one parenthesis, everything goes to poop. And there's your derivative. And then last but not least, this one says find an equation for the tangent line to inverse secant of x squared at the point 1, 0. What do I need for a tangent line? X, y, slope. X is 1, y is 0. Slope comes from the derivative. So if y is inverse secant, dy dx, all right, inverse secant says f prime over the absolute value of f times the square root of f squared minus 1. Okay, so the derivative goes on top, 2x. On the bottom, I have the absolute value of the end, the square root of the end squared minus 1, which is 2x, absolute value of x squared, square root of x to the 4th minus 1. And now I'm going to plug 1 into that, so dy dx at x equals 1 is 2 over 1 times 0, which is undefined. So my slope is undefined. If a tangent line has a slope that's undefined, that means you have a vertical tangent line, and a vertical line has an equation of x equals a number, and our number is 1. Okay, that's it. That's all I got for the video. So I will leave you with a terrible joke, terrible joke. What should I leave you with? Why don't monsters eat ghosts? Why don't monsters eat ghosts? Because they taste like sheet. It's terrible, but you loved it, right? It's the best.